In this video, I'm going to show how objects with different masses react differently to the same impulse. So I have here two marbles, marble 1 and marble 2. Marble 1 has a huge mass, and marble 2 has a tiny mass. Here's our experiment. I'm going to make marble 1 stationary, and I'm going to hurl marble 2, the tiny one, to the right. When 2 collides with 1, those marbles push on each other. And according to Newton's third law, marble 2 is pushed to the left just as hard as marble 1 is pushed to the right. We imagine there's no other force except for the force of their collision. Since these marbles feel the same net force, just in opposite directions, and because they interact for the same amount of time, they experience the same net impulse. Okay, but wait a second. If they feel the same net impulse, shouldn't each one have the same change in velocity? Let's find out. We're going to run the experiment and watch closely to what happens to number 2's velocity vector. Wow, look at that. What happened? Marble 2 initially had a big velocity to the right. When it bumped into 1, there was a huge change produced in that green velocity arrow. Here's the change that occurred. The velocity got really small, and then it increased all the way over to a really big negative value. So overall, that's a huge change in velocity. What about marble 1? Marble 1 felt the exact same net impulse, and yet its velocity barely changed at all. So why is this? The only difference between 1 and 2 is their mass. The bigger the object's mass, the less it reacts, or the less sensitive it is to an impulse. Objects like number 2 that are really tiny, when they feel an impulse, they will actually experience a huge change in velocity. So let's see this with numbers. These marbles feel the same impulse because they collide against each other. Marble 1, let's say it starts out with, this is the small marble here, marble 2, not 1, right? 2, yes. Marble 2 starts out with a velocity of about 1 meter per second. It's heading to the right, so positive. After the collision, it's going to the left, so negative, and it's almost the exact same speed, 0.9. Marble 2 has a change in velocity of 1.9 meters per second. That's if we ignore the sign. So 1.9 is the difference between 1 and negative 0.9. On the other hand, the really big marble 1, the really big massive marble, started at rest, and it was barely nudged at all. Only 0.05 meters per second was its final velocity. The difference between 0 and 0.05 is 0.05 meters per second. Marble 1 had a big mass, marble 2 had a little mass. The bigger the mass, the less sensitive it is to a change in velocity, or the less sensitive it is to an impulse. In other words, big objects are less affected by the same impulse. Little objects, on the other hand, will experience a much larger change in velocity. And that's what this shows. Let's watch one more time. The small object feels an impulse, which produces a giant change in velocity, whereas the big object feels a tiny change in velocity because of the impulse.